Today on Documentify TV, we're exploring how an ancient, massive ice sheet continues to shape the North American landscape and what that means for us in today's world. We are going out on a limb in today's video. We will discuss recent computer modeling research that can suggest that Earth's natural cycles over thousands of years can contribute to many chain reactions for the climate as a whole. This is not a carbon agenda, as mainstream may suggest. We support what is the most obvious from our own research we see with our own eyes. Earth is in constant evolution, changing gradually with warming, cooling, earthquakes, volcanic activity, and continental drift. What do you suppose this does to the planet over hundreds and thousands of years? The planet changes. That's what. So, this being said, let's get into the video, where we bring you the latest computer modeling study recently done that shows how the last ice age is still shaping and affecting the planet even today. Imagine a colossal layer of ice, thick and unyielding, stretching from Canada down through parts of the US, covering states like Pennsylvania, Ohio, Indiana, Michigan, and Wisconsin. This was the scene some 19 to 26,000 years ago when the Laurentide ice sheet ruled over much of North America. But what's truly remarkable isn't just the sight of this icy giant. It's what happened when it started to melt, and how that affects sea levels and land elevation today. Ph.D. candidate Karen Williams, alongside her advisor, Associate Professor D. Sarah Stamps, and collaborators Daniele Mellini and Giorgio Spada in Italy, has used advanced computer modeling to study these changes. Their research, published in Journal of Geophysical Research, Solid Earth, digs into how the land rebounded or sunk due to the melting ice, an effect scientists call glacial isostatic adjustment. Through nearly 130,000 computer simulations, Williams explored how this massive shift impacted the Earth's surface, oceans, and even gravitational fields. What she found is fascinating. In the eastern United States, the land is gradually sinking, contributing to rising sea levels in those regions. By contrast, eastern Canada is experiencing a slight upward movement, causing a local lowering of relative sea levels. To understand why some areas rise while others sink, Williams explained that it's critical to pinpoint natural and human-driven influences. In areas like the Gulf of Mexico and Chesapeake Bay, excessive groundwater extraction has led to additional land sinking, which compounds the effects from the ancient ice melt. Stamps highlighted that some of the biggest differences between the model's results and real-world observations appear in places with intensive groundwater use, like Houston, Texas. This study has practical applications too. Williams's findings will be essential for researchers and planners who guide decisions on aquifer use and coastal management. Her team's work will contribute to a comprehensive U.S. Geological Survey report to help communities, particularly in the Chesapeake Bay area, understand the financial, environmental, and social consequences of sea level changes. By refining our understanding of land movements, influenced by glacial isostatic adjustment, Williams believes we can better predict subsidence and sea level shifts, which will aid in planning for coastal hazards. Scientific models like these, backed by geological evidence, underscore the importance of using historical data to predict future changes and support resilience in vulnerable areas. That's it for today's video, folks. Let us know what you think in the comments. Until next time, see you in the next video, right here on Documentify TV.